Create pressure drop calculator using Miller's equation in VBA. So what I'll do, okay, this is Miller equation. Now this is a flow rate for Miller equation. The flow rate. So we want to calculate the pressure drop. So but first I need to add, let me go to menu. I can use this method to open menu, or I can right click on the form and select menu. Then now I will now add. So select this shell, click next, type in Miller equation for caption, then go to name, type in Miller equation, but there shouldn't be any space between them. Because if there is space there, it will reject it. Now let me also create window. Copy the window, paste it in name, click next, and then click indenting in. So I will not type in cascade, copy the cascade, paste it in name too, click next again, type in horizontal. Okay, I can also put in tile horizontal. Let me write it, tile horizontal, copy only horizontal, paste it in name, click next, tile vertical, type tile vertical in caption, tile vertical, and then copy vertical, paste it in name, click OK. Okay, now I've checked everything is okay. Now I click cascade. So what I will do now is say mdiform.arange 0 for cascade. Go back to the form, click tile horizontal, type in md, that's the address of the md form name, then type arrange space 1, then go also back to the form too, tile vertical, type in mdiform.arange space 2. That is for vertical. So we're done with that. So let's check if it works. Now we're going to open 3 forms. We open 3 forms to check if what we have done is okay. Yes, cascade, okay. Cascade is okay. Press the tile horizontal is okay. So you see he places this vertical. Okay, it's perfect. That's great. Now click this. Oh, we have not arranged that one. Let's go back to. Let's exit the form. Go back to I'll go back to the form again. So that will create the program form. Let's go back to the form. Okay, we have not created the form for mailer, so let's create a form for mailer. You can right click to create a form here, or you go to project, you add the form. You can right click, add the form, or go to projects to add the form. So now I need to change the back color to blue, which is the color I like. Then I change the name to frn mailer equation. That's what I type in the name, mailer equation, frn mailer equation. So that is that. Click, and then the caption I write mailer equation. Caption mailer equation. Then I will go to, let me look at okay, you have flow rate, you have internal diameter, you have pressure drop, you have specific gravity. So we also have okay, we have kinematic viscosity. So that means let's go back to, let's look at the form that matches what we have there. Okay, this one does not match it because this one has absolute pipe roughness, and in that other one there is no absolute pipe roughness. So okay, the one that could match it, shell MIT. Let me use shell MIT. Let me check shell MIT. Okay, this one matches it. This one is okay. So what I'll do, I'll copy this one. And go and paste it there. So we'll copy. We'll select all of them. And then click copy. Go to the form, the mailer equation form, open it, paste. You can paste like this one, go to the top, paste it there. The menu bar, there, paste, paste. Wow, I did not change the font for the form, because since I didn't change the font for the form, it will inherit the form, it will inherit the font character of the form, which is not good for me. So what I'll go to font, change it to Time New Roman, bold 16. So let me paste now. It will now be okay to take that. Okay, let me cut this off and add a frame. Let me remove it, add a frame. Let me take it off and add a frame to it. Let me take it off, add a frame. Now the caption of the frame, and then the caption of the frame, mailer equation. Change the back color. I need to change the back color to blue. I needed to adjust this thing so that when I paste this sort of frame, I copy it from shell MIT, it will not be more than this space. Let me expand it a little. Let me expand the frame. Value is okay now. Let me now paste. To overshoot, so it's okay now. It's okay. Let's go to Miller form now. Okay, what is this? Let's go to shell form. There's a code environment. Copy what is there because it's the same. Go to Miller form, paste it. So we have done that. We paste it there. We look at things that are not part of this, we delete them. So let's check. So let's add a class model for Miller equation. So say CLS Miller equation. CLS Miller equation. CLS Miller equation. Enter. Let's go to shell. Let's go to shell code environment. Copy the whole thing. So copy the whole thing and delete what we don't need. That is what we do. Copy the whole thing. Delete what we don't need. No. Copy the whole thing. Copy all of them and delete what we don't need. Copy. Paste. Delete this private constants, okay, for Reynolds number because there's no Reynolds number. There's no Reynolds number. Let's check if there's anything. Okay. Absolute pipe roughness. Delete it. Okay. Now we need to go to Reynolds number. We need to delete this Reynolds number function, this public function Reynolds number. So because there's no Reynolds number in the formula, so we'll delete it. Let's leave the pressure drop. We'll use it. We'll delete the friction factor. The friction factor is not part of what we're supposed to. It's okay. Wanting to make pressure drop the subject of formula. So PM equal to bracket open, and close. Let's Q divide by bracket open and close. And type in 4.06 6 times m. Go back 2 times. This is raised to what should be raised to power 2. Because taking the square root of both sides, so it should be raised to power 2. The whole of this should be raised to power 2. So and then go to the front. Press bracket open and close. So times and go into the bracket. specific gravity divided by internal diameter raised to power 5 raised to power 5. So this is the equation. So we'll copy the pressure drop equation, which we have which haven't rearranged the flow equation, the flow rate equation. We've got the pressure drop equation. So we'll copy the pressure drop equation into this other. Copy the pressure drop equation. Go to paste it here. We'll go and copy the other one, the Miller factor. Copy the Miller factor. Paste it inside then. Now we need to also need to go. So what we do, we copy this whole thing, these both of them, cut them. Copy, cut. So that equation is for customary units, and we should also use the equation for English units because they should be the same. So English unit doesn't have that. I needed to form the pressure drop equation for the XI unit. So what I'll do is PM equal to bracket open, another bracket open. So let me delete the front one. Let me treat the front bracket, the brackets close to Q. Try Q divide by bracket close, bracket open. Then I'll say 3.996 E there's exponential minus 6 times M times M times X. So now I'm gonna say raised to power 2. We'll go to the front, brackets open and close, then times, we go into the brackets, we say specific gravity divided by internal diameter raised to power 5. So this is the equation for pressure drop. I haven't rearranged the flow rate equation, so I need to copy it to that. So I'll paste it inside the XI unit area of the code. So the SI unit area of the code is below, which is the option customary tune. So I'll go down here. This is where I need to paste it. So I'll paste and enter again. I need to delete this. This is not part of the formula. This is for shell MIT equation, so I'll delete it. The shell MIT equation, so I need to delete that. So I'll just copy and edit. So I'll copy this. This one is for SI unit 2. I'll paste it now. So that is that. So paste it there. I'm now begin to edit. So what I do now, I need to copy this and also place it here in the English unit. So the only difference is that the flow rate is in gallon for English unit. So and then since it's in gallon, we need to convert it to barrel per day. So dividing it by 0.0291667 to be converted to barrel per day. So that's it. Then I will just start coding. I will say x. Let's say x is equal to 10 point. X equal to 10.0. Oh no, before I do that, let me define x and y. I need to define x and y. Okay, let's say 10.0. Well, let me define them. Let me define x and y. So dim x y as double. Now, so we need to define the variables. So do while x minus y minus x is supposed to say absolute bracket open, bracket close. This is less than 0.01. Now I will now say y is equal to x. Y is equal to x. Now here in this equation, I will now change the PM to y. I'll change the PM to y. And I'll change this to x, the PM on the other equation to x. Then here I need to put m as double 2, capital M as double. I'll come down here. I haven't defined the m. I'll say this is equal to this one is d is internal diameter. Type in internal diameter. And then this one is specific gravity. The SG specific gravity. I will just put in specific gravity there. This one is kinematic viscosity, so I'll just type in kinematic viscosity. So here specific gravity, change it to specific gravity. Specific gravity, this is internal diameter. Flow rate, the Q is the flow rate. So we're good to go. It's okay now. Then I need to type in loop, L-O-O-P, no, L-O-O-P, okay, L-O-O-P, that is that. So the pressure drop equal to X, the pressure drop equal to X. Close the gap, close the gap right now. Need to now copy the whole of that. So this is in PSI man. It's okay. So the same with this. So let me copy this formula. Copy. I needed to change that because the logarithm to base 10 in VBA doesn't exist, so it's logarithm to base E. So what I'll do, I'll copy this to OneNote, and so that I'll show you how the equation needed to be now. Let me open a new page. Remove click page, hide page title. Let me paste. So from here I say m is equal to log, bracket open, d raised to power 3 times specific gravity times pressure drop divided by viscosity raised to power 2, bracket close, to base 10 plus 4.35. Now to change this to base E, I will say log d raised to power 3 times specific gravity times pressure drop divided by viscosity square base E all over log 10 base E plus 4.35. So this is it. This is what the equation should be now. With this, VBA will recognize it, but with the initial equation to base 10, the VBA will not recognize it. So let's go back. Change it. So we're going to change this. We remove 10. We close all into. We close all of them into a bracket and divide it by log 10. Them into a bracket. Divide by log 10. Log bracket open. 10. Double close 10. Basically, so that is that. So it's properly arranged. So we'll do copy this. We'll copy the whole of this, paste it in English units, which is option cop summary unit 1. So what I'll do, I'll highlight these two equations, paste it in place of it. So paste it in place of that two equations. So I'll paste what I've copied in place of that two equations. So that is it. Now I will delete this, not part of what we, because that is for shell MIT equation. this is duplicated, so let me delete one of them. Now let's go to this. I won't copy and paste here because the formula for XI unit is different from that of the customary and the English unit, so they are not the same. So I need to write the formula here. Say x is equal to 10.0. Enter. Do. I'll say do. Let me use do until. Let me remove while. Let me use until. Do until absolute value of y minus x is until this is less than 0.01. Until this is less than 0.01. Oh, that means I made a mistake in do while. Do while is supposed to be greater than. Say until it's greater than. Supposed to be until it's greater than 0.01. So let me correct it in that other one. Should be until it's greater than 0.01. Because I wanted both of them to be the same. So the loop will continue until is less than 0.01, or the loop will continue while this is greater than 0.01, because I needed them to be the same. So that is that. So let's continue. Then I'll say enter y equal to x, and then I'll change this to, no, this one needed to come down, so I'll copy the Miller equation. I'll take the Miller equation up, the Miller function. Should I call it the Miller function or the Miller factor? Up. The Miller equation should be up. So let me arrange it properly. I'll change this to y, the PM to y. Change this to x. Then begin to edit this. So I needed to change the D to internal diameter. D is internal diameter. SG specific gravity. CP kinematic viscosity. Now you have this specific gravity. Then this one internal diameter. Then this flow rate. That is that. So we're done. We are done. Let's close the space in between. So okay, we need to type in the loop. And we also need to type pressure drop equal to x. We need to type the pressure drop into equal to x. So looking at the units. Looking at the units. This one barrel per day quota 0.029667 gallon per gallon per minute. I need to delete this because it's not part of what we didn't use it. We need to delete that constant. That constant was not part of what we used. Let's open the form. Let's check. I've not created the mailer equation. That is the module. I've not created it, so let me just create it. Yeah, I'll copy the shell MIT equation and paste it. So since they look similar, paste it into the mailer equation and begin to edit. I will remove the file address for shell MIT and put the one of mailer equation. So I also need to change the class to mailer to CLS mailer equation. The same to this other one. Change the class to CLS mailer equation. And then let me check if there is anything I needed to update there. Okay, I need to remove the friction factor and the Reynolds number. They are not part of this. They are not part of this, so I need to delete them. They are not part of it. So let's check if there is any other mistake along the line. I don't think there is any mistake now. So let me go to the class mailer equation again and check. Let me check if there is any mistake. Okay. Let me change this to from mailer equation. Change address to FR mailer equation. Let me go through if there is any error or if there is any duplicates that will interrupt the program when I run it. Any duplicate that will act as a bug. Let me go through. This one, there is a duplicate, so I delete one. Let me just delete this. Delete. It's a duplicate. When I copied, I didn't edit that. I didn't edit it properly, so let me check again. Click. I did not form the code for this. Let's close. Let me close. Let me form the code now. need to say form Miller equation dot show, so it will show. Let's go back. Miller equation, pressing F8, F8, let me check. Shell MIT Miller equation, the two, that means it was not properly edited. So let me check. Let me make the Miller form, make the MDI field, let me make it true. MDI child, let me make it true. Let me check again. I believe for this thing to be showing, it shows that there is, maybe I did not properly edit what I copied. The copy and paste I did, it was not properly done. Let me go to, press F8, press F8, let's check. The shell MIT equation is still coming up, so it shows that what I copied, I did not properly edit it. So that means some part of the address is bearing shell MIT. Let me check. This one is okay. Let's go to the form. This one is shell MIT equation, so I need to change it. The address is wrong, so I need to change the address to FRM Miller equation. I'll delete that, change address to FRM Miller equation. It's the wrong address, that is why that form is coming up. This one is also wrong. Let me change it also to FRM Miller equation. The address is wrong. See, I copy and paste, I didn't edit properly. So this, I need to change this address to FRM Miller equation. Go down, the same here, FRM Miller equation. So let me save this form I created. So the form and the module and the class module that I created for Miller equation. So let me open again, click the F8 till F8. Then let me check form again. Let's look at it. Let me select English. Let me check the units I'm supposed to select. Okay, it's the English unit I'm supposed to select because the flow rate is in gallon per minute. So select the English unit. We'll select the English unit. Select the English units. Press F8. F8, 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 F8. Go to that. Viscosity is in centipons. It's not in centistoke. So let me close and change it to centipons. 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 CP. Centipons. Let me check centipons again. So we'll take English unit. This means I should calculate CP. The CP should be specific gravity times kinematic viscosity. So 15 times 0.825, which is 12. Let me right click, select all, copy, paste inside the text box for kinematic viscosity. So the flow rate is 3000, this is 0.825, this is 14, this is 0.250, this one let's say 1 mile. So let me calculate, let me solve ambiguity. Okay, that means this solver 4 has been used before, so I need to change it. So let me go to the class model for Miller equation. There I will change, I will make it okay. Let me change this to Miller equation. Let me change it to Miller equation. Miller equation. Copy. Go to yes. That means I didn't change this log, because knowing that this log 10 doesn't exist. Let me change it. Okay, let me just bracket close, all of them in brackets close. Divide by log 10, log bracket open 10. So let's solve. Let's look at the answer. 25.02 correct. This is the correct answer. Very correct. Let's look at what they got. The same 25.02. After by successive iterations, they got a final value on this. So very correct. Very, very correct. That was a perfect. So perfect. Great. That's good. So but the friction factor is not there. It's not in those formulas. So I will delete them. I'll delete the friction factor. the Reynolds number, and the fluid velocity. Let me delete it for now, but next time I might use the pressure drop, the flow rates, and the kinematic viscosity to calculate the Reynolds number, the friction factor, the fluid velocity, and insert them there. I might do that, but that might be next time, or so let me just delete them now since they are not part of it. Delete, not part of the formula. They did not lead to so let me arrange this properly now. Align with the text box up there, left, align left, and select this and this, and remove the space, the horizontal, okay, align top, remove the horizontal space, is properly arranged now. Now it's properly arranged. Go to this place, remove some of those label and text box for kinematic and velocity, which I deleted. So let me remove them. Fluid velocity, let me remove them so that it will not cause problem while running the program. Let me delete them. It's like the kinematic viscosities are not there. Okay, those ones doesn't have units, so those ones doesn't have units. Let me see. This is paste. Okay, let me go to the calculator again and copy, paste, come here, 3000 barrel 0.825. I need to change it to English. This is 14, this is 0.250. This one is 1 mile. So great, that's accurate. That is great. Great. There is a mistake here. I supposed to copy this thing. It's still. So it's okay now. It is okay. Let me save. Great. Thank you for watching. Thank you for watching.